There's something massive out there, 10-20 times Earth's mass, orbiting in darkness. It's never been photographed, but its gravitational fingerprints are everywhere.
Planet 9, the hypothetical massive planet beyond Neptune that astronomers Mike Brown and Konstantin Batygin proposed in 2016 based on orbital anomalies.
Extreme trans-Neptunian objects cluster at a specific angle and direction. That's not random. Something is shepherding them into similar orbits.
That angle? 18 degrees. The same signature we see in impact craters across the solar system. Planet 9 is the delivery mechanism.
Planet 9's proposed orbit, 400-800 astronomical units from the Sun, highly elliptical, taking 10,000-20,000 years to complete one revolution.
When it swings through its perihelion, closest approach to the Sun, its gravity disrupts the Oort Cloud and Kuiper belt, sending icy bodies inward.
Those icy bodies become the comet swarm. Some pass through harmlessly, others hit planets. The ones that hit us 12,500 years ago, those came from Planet 9's last passage.
The Oort Cloud contains trillions of icy bodies, loosely bound to the Sun at distances up to 100,000 AU. Planet 9 stirs this reservoir like a spoon in cosmic soup.
When Planet 9 last passed through, its gravity kicked objects out of stable orbits. Some fell sunward, others got ejected from the solar system entirely.
The ones that fell inward became the nitrogen ice comet swarm, Antarctic core, Mars' Hellas basin, Pluto's Sputnik Planitia, all fragments from the same delivery.
The 18-degree inclination is the key signature. Planet 9's orbit is inclined 18 degrees to the ecliptic. Objects it perturbs inherit that inclination.
Look at trans-Neptunian object orbits. Sedna, 2012 VP113, 2015 TG387, all have similar inclinations and perihelion alignments. That's Planet 9's calling card.
Why hasn't anyone found it yet? Because it's so far away and dark. At 600 AU, even a Neptune-sized planet reflects minimal sunlight.
Current telescopes struggle to detect it, but new facilities coming online, like the Vera C. Rubin Observatory in Chile, have the sensitivity to finally spot it.
If Planet 9 exists and has a 20,000-year orbit, then 12,500 years ago was its last perihelion passage. Next perihelion, 7,500 years from now.
That gives us time, but not unlimited time. The cycle repeats. When Planet 9 comes back, another swarm gets delivered. We need to be ready.
The physics of orbital resonance explains how Planet 9 creates clustering. It's not pulling objects directly. It's modifying their orbits through repeated gravitational tugs.
Think of a playground swing. Small pushes at the right frequency build up amplitude. Planet 9's repeated flybys progressively alter trans-Neptunian orbits.
Over millions of years, this creates the clustering we observe. But during perihelion passage, the effect intensifies. Objects get kicked inward rapidly.
The comet that became Antarctica likely originated in the Oort Cloud, got disturbed by Planet 9, fell inward over centuries, and arrived around 15,000 years ago.
As it approached, tidal forces from the Sun and planets began affecting it. At the Roche limit, 8,000 miles from Earth, tidal stress ripped it apart.
The core, being most cohesive, punched through. Smaller fragments scattered. Some hit immediately, seeding the Ice Age. Others took centuries to spiral in.
This explains why the Younger Dryas lasted 1,200 years. It wasn't one impact. It was sustained bombardment from a debris stream following the main core.
Like Comet Shoemaker-Levy 9 hitting Jupiter in 1994, a string of fragments impacting over days, but our event lasted centuries.
Planet 9 itself. Where did it come from? Most likely it formed in the inner solar system alongside the gas giants, then got ejected outward early in solar system history.
Gravitational interactions with Jupiter, Saturn, Uranus, and Neptune could have flung a fifth giant planet to the outer reaches where it now resides.
Or it could be a captured rogue planet, formed elsewhere, passing through our system and getting gravitationally trapped by the Sun's influence.
Either way, it's out there now, silently orbiting, periodically stirring the Oort Cloud and sending reminders our way.
The dark nebulae concept from the book. Could the Oort Cloud itself have originated from interstellar clouds the Sun passed through?
As the Sun orbits the galactic center every 225 million years, it encounters different galactic environments, dense clouds, sparse regions, spiral arms.
When passing through a dense molecular cloud, the Sun could capture material into orbit at extreme distances, building or replenishing the Oort Cloud.
This means the Oort Cloud is dynamic, not static. Its composition changes based on what the Sun encounters during its galactic journey.
The nitrogen ice bodies specifically suggest capture from a cold, pristine environment, exactly what you'd find in a dark molecular cloud.
Triton, Pluto, comets, they all show nitrogen ice. That might be the signature of material captured from one specific cloud encounter.
If Planet 9 is a captured body, it might have brought its own retinue of icy objects with it, adding to the existing Oort Cloud population.
This would explain why some Oort Cloud objects have unusual compositions or orbits. They're immigrants from another stellar system entirely.
Now consider the late heavy bombardment, mainstream science's explanation for extensive cratering on the Moon and inner planets around 4 billion years ago.
What we're proposing is that bombardment events are periodic, not ancient one-time affairs. When Planet 9 passes through, bombardments happen.
The late heavy bombardment might actually be the latest heavy bombardment, the most recent of many cycles stretching back billions of years.
Each cycle resets the solar system somewhat. New craters form, old ones get partially erased, and life has to adapt or perish.
On Earth, plate tectonics recycle the crust, erasing ancient craters. But on bodies without tectonics, Moon, Mars, Mercury, craters accumulate.
The crater distribution might show clustering at specific time intervals matching Planet 9's orbital period. We just haven't analyzed it with that framework yet.
Future missions to map crater ages precisely could reveal the periodicities. 20,000-year cycles of bombardment hidden in the crater record.
Sediment cores from Earth's oceans might show similar periodicities: iridium spikes, impact spherules, extinction events clustering at regular intervals.
The terrifying implication: this isn't a one-time disaster. It's cyclical. Planet 9 will return, and when it does, another swarm will be delivered.
But knowledge is power. Unlike our ancestors 12,500 years ago, we can detect incoming objects, potentially deflect them, and prepare shelters.
NASA's Planetary Defense Coordination Office already tracks near-Earth objects, but their focus is asteroids in the main belt, not Oort Cloud comets.
Oort Cloud comets are more dangerous because they come in fast and with little warning. By the time we detect them, they could be months away.
We need an early warning system monitoring the outer solar system for perturbations. Detect objects being kicked inward before they're already on approach.
The Vera Rubin Observatory, once operational, will survey the entire visible sky every few nights. It might give us the warning system we need.
Next episode, the synchronization. Niagara Falls, Saturn's rings, Pluto's plains, human settlements, all the independent clocks pointing to 12,500 years ago.
We'll prove the timeline through multiple independent dating methods, showing this wasn't gradual change, but catastrophic synchronization across the entire solar system.
Subscribe to Track Planet 9. Tell us what you think should be done to prepare for the next passage. The cycle repeats. We have 7,500 years to get ready.